All right, so now in example 6, we're looking at the function square root of x to the x power. So it might be daunting just to see that square root of x in the base, but it turns out if we follow the same process that we did in, say, number 5 and number 3, that radical is going to get reduced substantially when we start applying our log rules. So let's see how this works out. So first things first, set the function equal to y. Now apply logs to both sides. So you have natural log of square root of x to the x power. And then we need to use log rules. So we have this x, that's going to move down in front. So carrying that out, we have x natural log of square root of x. It's like, okay, now how do we handle this radical? Well, you have two options. You can either worry about it later when you deal with the product rule, and then you're going to have to use the chain rule on the natural log of square root of x. Or we can notice right now that this is the same thing as x natural log of x to the 1/2 power. So then this gives us an exponent on the thing on the inside of the log, which can also be brought out in front. So this gives us 1/2 x natural log of x. So that makes our derivative life a lot easier. All right, so now that we've used basically every log rule that we possibly can here, what we're going to do is derive both sides. So deriving the left-hand side, this is going to give us y prime over y, as it always does in these sorts of problems. And then on the right-hand side, we have to use the product rule on these two functions here. So we have to derive the purple underlined one first. So we have, what's the derivative of 1/2 times x? That should just be 1/2. Then you leave the second one alone. Then you add on, you leave the first alone, and then multiply by the derivative of the second one, which is just going to be 1 over x. Noting now what we can cancel, we have this x and this x, they kill each other. So, rewriting this a little bit, we have 1/2 natural log of x plus 1/2, and that's as simplified as the right-hand side gets. You could factor out a 1/2 if you like. Yeah, why don't we do that? 1/2 natural log of x plus 1. I just factored out the 1/2. All right, now the final step, well, second final step, we're going to multiply both sides by y. All right, so rewriting, we have y prime is equal to 1/2 times the natural log of x plus 1 times y. What's that equal to? Well, we know our y is equal to square root of x to the x power. So every place we see a y, down below, we're going to replace it with our original function. So we have 1/2 natural log of x plus 1 times square root of x to the x power. There are no more y's on the right-hand side, and we have y prime by itself. That's exactly what we were after. So that's it. Final answer. Done.